Hello. Today we will be looking at continuing the theme of redox reactions, combustion. This relates to the topics of classifying chemical reactions. Today we are going to talk about reactions that play a very important role in our lives, such as combustion, which we use almost every day. Combustion is an example of redox reactions that we will talk about today. Let's start with the combustion reaction. A combustion reaction is a reaction that always takes place necessarily with oxygen. Oxygen is an essential substance that is involved in this process. In addition, this reaction is always exothermic, which means that heat will always be released during this reaction, and the heat will always be written as on the right side of the equation. In addition to that, this reaction is always, as a general rule, if it's a combustion reaction, it very often involves the release of flame, and it's flame we can see when we set some substances on fire. Then in this case we speak about this reaction not just as combustion, but we say that it is exactly combustion, which is accompanied by flame emission. Let's see what kind of example we could give. Let's say this is a reaction going on between an organic substance. This substance is called methane, and the methane reacts with oxygen. In this case, the reaction produces carbon dioxide when completely burned. Water is released, and necessarily there's a release of heat. Recall that in this case we must necessarily equate the chemical equation. Here we go. Carbon on the left side 1, on the right side 1. Hydrogen on the left side is 4, on the right side is 2. To the formula for water, we'll put a factor of 2. Oxygen on the left side is 2, on the right side is 4. We'll put a factor of 2 in front of oxygen. I would like to point out that the stuff we're burning is made up of carbon and hydrogen, so the products of the reaction will always be carbon dioxide or carbon dioxide. And this substance is obligatory in complete combustion, and secondly, water is obligatory. In this case, it is quite easy to prove that it is these substances that are emitted. For example, carbon dioxide is a gas which does not support combustion. It can be proved with the help of a special substance, calcium hydroxide. And the emission of water can also be fixed with the help of certain chemical experiments. But let's take another example. In this case, we'll also use the oxidation reaction. The substance I'm going to take is called glucose. Glucose is a substance that is a carbohydrate, and glucose, when it is oxidized, and for example, when it happens inside our body, it doesn't burn, of course, but it can be oxidized by the oxygen that we inhale with the air. So in this case, we won't see a flame, but the same reaction products are formed: carbon dioxide, water, and of course heat energy. Well, again, we need to equate this kind of interaction. Carbon on the left side is 6, on the right side is 1, so before CO2 we will put 6. Hydrogen on the left side is 12, on the right side is 2, and so in this case we will also put a coefficient of 6 before water. Oxygen on the left side is still 8, but on the right side it is 12 plus 6, 18. But of these 18 we already have 6 in glucose, and so before oxygen we need to put a coefficient of 6. As you can see, the equation is quite complex, and in addition, we can give an example of combustion and other substances. And combustion in this case does not necessarily include the presence of carbon and hydrogen. Burning can, and other substances, for example, such as substances hydrogen sulfide gas, that can also burn. The reaction produces water. That's understandable because hydrogen with oxygen forms water, but sulfur with oxygen in this case forms sulfur oxide, CO2, and of course heat energy. We start equating, and so hydrogen on the left side is 2, on the right side is 2, sulfur on the left side is 1, on the right side is 1, oxygen on the left side is 2, on the right side, notice it's 3. So in front of the oxygen formula, there should be a factor of 3 seconds, but fractional coefficients are not allowed to make up. Then all the coefficients are put up, we multiply by 2. Then we put a coefficient of 2 in front of the hydrogen sulfide formula. We put a coefficient of 3 in front of the oxygen formula. To the water formula, we put 2, and to the SO2 formula, we put a coefficient of 2 in this case. Unlike the previous reactions where in addition to the water we have already mentioned, in this case we get sulfur oxide, and this substance accordingly is also an oxide. Thus, in this case we get oxides. Water in principle is also an oxide, and the substance hydrogen sulfide in this case also enters into this reaction. That is, it is not necessary for the combustion reaction to be, for example, carbon and let's say hydrogen, as you can see, and hydrocarbons, and a compound where there is oxygen in addition to carbon and hydrogen, and it can be a compound where there are other chemical elements. Well, to give you another example, a compound that's used in the first stage of making sulfuric acid, it's a substance called peride, and it also burns. As a result of the combustion, iron combines with oxygen to form iron oxide ferrum T2O3, and the second product of the reaction is sulfur dioxide or sulfur oxide I4, and of course heat energy. Let's start equating. So iron on the left side is 1, on the right side is 2, so we put a 2 in front of the formula ferrum C2. Gray in this case became 4, here it's 1, 4 in front of CO2, and then counting oxygen, here it's 2 and here it's 3, and then 8, 11, but then 11 by 2. Again, we can't divide to get a whole number. Then we got all the coefficients, we multiply again by 2, and then we get a coefficient of 4 in front of the ferrum C2. In front of the oxygen formula, we put 11. In front of the ferrum 2 formula, O3, we get 2. And in front of the formula CO2, we need to put a coefficient of 8. So it turns out like this. And besides sulfur oxide 4, in this case, we also got iron oxide of valence the third, and this compound here is also an oxide. This reaction has a very important relation to the production of sulfuric acid, this being the first step of this method of producing sulfuric acid in such production. As you can see, as a result of the combustion reaction, once again we emphasize we always involve oxygen. Pay attention, it is in all our examples. As a result of the reaction is always released oxides. So in the second place is always obtained will be oxygen. And if the compound consists of carbon and hydrogen, carbon, hydrogen, and for example, oxygen or nitrogen, so can also be present here, then at full combustion will always be released carbon dioxide and water. But as we have shown below, the last two examples, other substances can also burn, such as those containing hydrogen sulfur, metal and sulfur, and such substances also undergo combustion. In any case, these processes are called combustion, oxidation, but oxidation can be accompanied by the emission of light, for example, when methane burns, but when, for example, glucose is oxidized, in this case, the emission of light is not necessary. But if light emission occurs, then we say it's a combustion reaction. Judging by the fact that we have given an example, I really hope that in such equations, and they can be very complicated, you will not get confused and will arrange the coefficients correctly. I hope that's clear today. Goodbye.